Let's look at data transmission in computer networks and specifically the packets that we're using for that. So in modern computers, data is usually stored in files, and these files can be small, large, or very, very large. So one might assume that when we transfer a file from one computer to another, the whole file is just sent as a continuous stream of ones and zeros over the telecommunication networks. And this would be the best way to do it maybe in an ideal network. Error-free with infinite communication capabilities. But real networks are not like that, obviously. They have errors and they have finite communication capacity, which is called bandwidth. So we need to deal with that. So if a computer sends a large amount of data over a network without any pause, it will cause other computers to wait while the data is being moved. And this would disturb the communication of the rest of the user. And then think of what happens when there's an error. Then a large amount of data has to be retransmitted over the network, which would just add up to more traffic to the network. So to minimize these effects, what we do is we split large data units and we reformat them into smaller packages, because this allows for better network sharing and better management of errors in the transmission. So this makes it also possible to mix packets from different users if an error occurs. So then if an error occurs, you only have to resend a small section of the data and not the whole big file again. And then it's relatively easy to recover from this error. So in order for many users to transmit at once data quickly and access the network, we break data into small, manageable chunks. And these chunks are normally called packets or frames. And although the terms packets and frames are often used interchangeably, there are some differences. And this is because the communication process in the computer network is organized in layers. And the word frame is usually used to name the data aggregation in lower layers, and the word packets is used in layers that sit above them. So a packet or a frame needs a way to mark its beginning and its ending, and it needs to carry some control information. So different communication protocols use different conventions for distinguishing between the elements of the packets and for formatting the data. So for example, in a lot of point-to-point protocols, the packet is structured in 8-bit bytes, and special characters are used to delimit the different elements. And there's other protocols, like for example the Ethernet, and they use a special sequence of bytes to mark the beginning and the ending of a new frame. So these are just some protocols that organize their packets as bytes, but this is not always like that. There's also protocols that defines their packets at bit level instead of byte level. But what most of the packets and frames have is that they have a header, a body, and a footer. So if we look at an IP packet, for example, we can see that in the header we have information about the destination address, the IP address of the packet. There's information about the length of the packet. There is information of the originating IP address. The header also includes the packet number in the sequence of packets. It establishes the protocol to determine the type of package that is being transmitted. So let's say audio or video, email, web pages, etc. And the header contains information to perform any error checking operation. Then the packet body, which is also called payload, contains the actual message that is being sent. And the packet footer, that is optional, contains a sequence of bits that indicates the end of the message. And it also may contain some information that we need to perform some error checking operation, for example, at the receiving end. So error detection and correction is performed at various layers in the protocol stack. And network packages for that contain things called checksums or parity bits or cyclic redundancy checks. And all of these are mechanisms devised to be able to detect and correct errors that occur during the transmission of a packet by operating with the transmitted data. So at the transmitter side, a checksum or a parity bit or a cyclic redundancy check code is calculated before the package is being sent. So this code is transmitted with the data, and when this data is received at the destination, the checksum is recalculated compared with the one in the packet. If discrepancies are found, so if it's not the same, then it means that the packet may be corrected or discarded. And any packet loss is dealt with the network protocol. So simple protocols, simple codes allow only for detection of errors, while more complex codes can correct up to a certain number of errors. And in many cases, modification of the network packet may be necessary while routing. And in this case, checksums are just being recalculated. So under fault conditions, packets can end up following a closed circuit. And if nothing is done to avoid it, the number of packets recirculating could build up until a network is congested, for example, at the point where it will actually fail because of congestion. A time to live is a field that is in a packet, and it's decreased each time a packet goes through a network node. And if the field reaches 0, routing has failed, it's assumed, and the packet can be discarded. And this way it doesn't fill up the network. Ethernet packets do not have a time to live field, and so they are actually subjected to what is called a broadcast storm in the presence of, for example, a switch loop. So we have looked a little bit at packets in data transmission in computer networks.